Hello students, welcome to the session. So topic for today's session is vector algebra. So in this we will discuss about the basic definition of vectors. So what are vectors? Let us first clear this term. See, a vector representation is look like this. So it is an arrow form where your this portion represents the magnitude, or you can say the length. Okay. So this is the symbol by which we are denoting the vector, and it is the direction. The arrow is representing the direction. Clear? So magnitude and direction, the term which has both magnitude and direction is called your vector. Clear? And in this is called your initial point. This is called your initial point, and this is called your terminal point. This is called your terminal point. Clear? Okay. Now, first we will understand what is a position vector. The first term we should know the position vector. So what is a position vector? See, now we have a coordinate system like x, y, z. We have a coordinate system x, y, z. So this is the positive, and the negative side is also there. It is a perpendicular side. Okay. So we have a coordinate system like x, y, z, and this is your origin 0, 0, 0. Okay. So if you have your point P somewhere here, it is xyz type. It is in a 3D form. Okay. So what is the position vector of x? So always position vector. So the position of the vector, if we are writing position vector, so it is always calculated from the origin. It is always calculated from the origin. It is always calculated from the origin. Clear? So position vector is always calculated from the origin. So OP vector will be your xi cap plus yj cap plus zk cap. So position vector is your xi cap, yj cap and zk cap. So what is I cap, j cap and k cap? So it is your unit vectors along the x-axis, y-axis and z-axis. Unit vectors along the, this is your I, it is your j, and it is your k. Along the x-axis I cap, along the y-axis j cap, and along the z-axis k cap. So position vector is always measured from the origin. Clear? So we should be very much clear about the position vector, definition of the position vector, because it is always asked in the question. Now we will learn some operations. Let us take two vectors, a vector. So always the vectors comes in a components like I cap, a1, a2, j cap plus a3, k cap in all the three directions I, j, k, x, y, z, axis. If I have b vector like b1 I cap plus b2 j cap plus b3 k cap. Clear? So now let us discuss about the first addition. So addition of a two vectors, see, if I have a vector plus b vector, then we have to add the component wise. So first we will write a1 I cap, a2 j cap plus a3 k cap plus b1 I cap plus b2 j cap plus b3 k cap. So that will be your a1 plus b1 I cap plus a2 plus b2 j cap plus a3 plus b3 k cap, right? So we have to add component wise a1 b1, a2 b2 and a3 b3. Similarly for subtraction we have to a cap minus b cap. So we have to write the values of a vector a1 plus a2 j plus a3 k minus b1 I cap plus b2 j cap plus b3 k cap. So this will be your a1 minus b1 I cap plus a2 minus b2 j cap plus a3 minus b3 k cap. This is your addition and subtraction. All addition and subtractions are done by component wise. Okay. Similarly, if you have a scalar multiplication of a vector, scalar multiplication so scalar multiplication is represented like ma. M is a some scalar number, a positive, negative, anything. So m, and a vector we know a1 I cap plus a2 j cap plus a3 k cap. This will be your m a1 I cap plus m a2 j cap plus m a3 k cap. This is your scalar multiplication. And the fourth one is very important. If two vectors are equal, that means their components are also equal. That means my a1 I cap plus a2 j cap plus a3 k cap will be equal to b1 I cap plus b2 j cap plus b3 k cap. So that means your a1 equal to b1. If two vectors are equal, their components are equal. I component will be equal to I component, j component will be equal to j, and k component will be equal to k. So a1 equals b1, comma a2 equals b2, comma a3 equals b3. Clear? So this is your equality of two vectors. These are the basic terms you should know. Okay. So now the fifth term you should know, magnitude. How to calculate the magnitude of a vector. So if a vector A is given, a1 I cap plus a2 j cap plus a3 k cap. Now the magnitude of A is represented by this notation, and it is like a1 square plus a2 square plus a3 square. Clear? Now let us check whatever we have discussed. Let us do some examples based on this information. So find the value of x. Find the value of x and y so that the vectors 2i plus 3j and xi plus yj are equal. Okay, so they are saying that we have to find the value of x and y so that the vectors are equal. These vectors are equal. Okay, they have given that these two vectors are equal. So that means if two vectors are equal, let us say if I let my this vector is a vector is equal to 2i plus 3j, and if my this b vector is equal to xi my plus yj. So if we have a vector equal to b vector, that means you have 2i plus 3j equals xi plus yj. That means 2 equals x and 3 equals y. 2 equals x and 3 equals y. Clear? So if two vectors are equal, that means their each components are equal. So you have to compare the components and you have to find the respective values. Clear? Next question. Let's discuss the next question. Let O be the origin. Let O be the origin. Let O be the origin and let P is your minus 4, 3 be a point in the xy plane. Express OP in terms of vectors I and j. Also find OP vector. Clear? So let O be the origin and let P minus 4, 3 be a point in the xy plane. O be the origin and let minus 4, 3 be a point in the xy plane. So we have x plane, y plane and z plane. If your P has, okay, we have only xy plane. let us, if it is like this xy, so that means your z component is 0. So you have a point p at minus 4 comma 3 something, and it is your origin 0 comma 0. Now express op in terms of ij. So we know that the o is a op vector. That means you have to find the position vector. So we have to find the position vector op. So it will be, so all the position vectors are from the origin, so we will write as minus 4i plus 3j. Okay, so okay, now let us decode this op in another way. So here op vector we can write as position vector. See, if any vector is, every vector is generally taken from the origin. So OP vector, so every vector if it is taken from the origin, the position vector, so we will just write minus 4i and 3j. Now if it is a OP vector, so we can decode like this: position vector of P minus position vector of O. See, the position vector of P means just you have, it is in xy plane, right? It is in xy plane, so we will write as 4i plus 3j position vector. So it should be written in the vector notation. Since minus 4 comma 3 represents your Cartesian plane, but your I and j, if you introduce your I and j, that means it is your vector representation, and the position vector of 0 is always 0i plus 0j. So 0 is also can be written in the vector form like 0i 0j 0k. Okay, so if you multiply with respect to the component I component, you will get your minus 4i, and if you do the calculation with respect to the z and j, you will get your 3j. Clear? So it is your op vector. So it is your OP vector. So in any way, if it is a origin, then you can write directly minus 4i and 3j, that whatever is there, or this is the main theory behind that. Okay, now what they are asking now, the magnitude. Now you have to find the magnitude. So what is the magnitude? Magnitude means the square root of the component, each component. So it is your minus 4 square plus 3 square. It is your root 25. Answer is 5. Clear? Magnitude is always positive. Clear? Now let's check one question based on equality. If two vectors are equal. Okay, now let's position vector. Let's discuss an example on position vector. If A is your 0 comma 1, if your B is 1 comma 0, your C is 1 comma 2, and your D is 2 comma 1. To show AB vector equals CD vector. Clear? To show your AB vector equals CD vector. So AB vector, okay, so we have to find the AB vector. See, in this whole picture you have given only the coordinates in Cartesian form, but we don't know the vector form. So we will deduce this the vector form. So AB vector means the position vector, position vector of B minus position vector of A. So what is the position vector of B? B means position vector of B. Always this represent in I cap and j cap, so 0j, and your position vector of A is your 0i plus j. So minus it, you will have I minus j. Now your CD vector means position vector of D minus position vector of C. Clear? So what is the position vector of D? Position vector of D is your 2i plus j minus position vector of C is your I plus 2j. That means your 2i minus I will be your I, and j minus 2j will be your minus j. So what they are asking to show they are equal. Yes, they are equal because their components, I component is same and their j component is same. So therefore AB vector equals CD vector. So in this we have done the position vector. We have find the position vector. How to find the position vector? How to find the vector through the position vector concept? We have to do like this, and then they are asking, are they equal? Yes, they are equal, because their each component, I component and j component, coefficients are equal. So in this way, we have to proceed the question. So that's all for today's session. I hope you understood the topic well. If you have any doubt, you can contact me through Urban Pro Profile app. Till then, revise and thank you.